In this video, I will be explaining some simple cases of orthographic projection of lines. We know that orthographic projection of any object can be obtained on three mutually perpendicular planes. Those are vertical plane VP, horizontal plane HP, and profile plane PP. Based on the position of a line relative to the reference planes, different cases are considered here. Out of these 4 cases, I will be explaining first 3 cases in this video, and fourth case I will explain in my next video. The first case is a line perpendicular to one reference plane. That is, if a line is perpendicular to HP, it will automatically be parallel to vertical plane, and if a line is perpendicular to VP, then it will be parallel to horizontal plane. Now second case is the line which is parallel to both the reference planes, that is horizontal plane and vertical plane. And third case is which I will consider here is line inclined to one plane and parallel to the other reference plane. Now to draw a line, to draw orthographic projection of a line, some of the following information may be required. Not all information will be given. Sometimes these are the main information which we require. Any of these 3 can be given. So first is actual length of the line, which is called true length. Position of any of the points of a line, preferably endpoints. Sometimes middle point, position of middle points are given. And third one is a line's inclination from HP. We represent that inclination, that is inclination of line from HP, we represent that by theta, and inclination from VP we represent here by phi. So out of these 3, some of the information may be given. Based on that, we can draw orthographic projection of a line. Let us take first example of a line perpendicular to HP and parallel to VP. Now these are the 2 planes. This is vertical plane and this one is horizontal plane. And now let us take now the intersection of these 2 planes. We know that intersection of these 2 planes, intersection line, this is our XY line or reference line. Now this is our actual line. Name them AB. AB is the actual line which is perpendicular to HP and parallel to VP. When you look from this side, you will be getting front view in VP. Now you can see that this line will appear here. This line will appear here, which is perpendicular to the XY line, and whatever be the length of AB, that is true length of AB, is visible in front view, that is in VP, and this line is perpendicular to XY line. And when we look from the top, both points A and B, when you look from the top, both A and B will coincide and it will appear as a point only. This entire line will appear as a point. Now we know that we rotate this horizontal plane in clockwise direction for 90 degree, and this is what we will be getting in our drawing sheet. A line in front view, A dash B dash, we know that in front view we represent by dash. Small letters, this is capital A is now small a dash, capital B, small b dash. Now these both points are represented here in top view in a single position, a single point, that is A and B. Similarly, now take another example when a line parallel to both HP and VP. Now this is the case where line is both parallel to HP and VP. Now this is a line AB which is parallel to both HP and VP. Now what is the meaning of parallel? Parallel means all points are at equal distance from VP. If all points are at equal distance from VP, then that line is parallel to VP. Similarly, all points of AB are at equidistance from HP, then that is parallel to HP. Similarly here, you can see that all points, that is A and B, both points are at same distance from VP. That's why this line is parallel to VP. Now here in this case, for front view, you can get front view. Mark these 2 points as A dash and B dash. Now you can see that when you look from this side, you will be getting a line which is of same length. The same AB, whatever be the true length, the same true length will be getting in front view, and that line will be, that front view will be parallel to XY line. Now this line is parallel to XY line. Similarly, when you look from top, you will be getting another line, you will be getting shadow of AB when you look from the top, this line is also parallel to XY line and is of same length whatever is the length of AB. So this is my top view, and this is what you will be getting after rotating this horizontal plane 90° in clockwise direction. Both plane will come at same position, same line, and you will be getting these two, front view and top view. Now let us take two examples. One is draw the projection of a line PQ which is 50 mm long, kept parallel to both HP and VP. Now this line PQ, its true length is 50 mm and it is kept parallel to both HP and VP. So we know that in front view and top view both we will be getting lines which are parallel to XY line. So first step is you have to draw this XY line, and then in this XY line you will be getting two lines, two views which are parallel to XY. Now where are those two lines? One is 15 mm above HP, so just take this distance as 15 mm. So 15 mm height, draw a line parallel to XY line, and this length, true length, that is length will be 50 mm, draw a line of 50 mm length at a distance 15 mm from XY line, and you will be getting front view of the line PQ. Similarly top view you will be getting at 20 mm distance. So from XY line take 20 mm distance and again draw a line which is of same length 50 mm PQ. You will be getting PQ at a distance of 20 mm. Now remember this, P dash and P will always come in same vertical line. Q dash and Q will always come in same vertical line. Now second case, draw the projection of a line PQ 50 mm long. Again the line is PQ and its length, true length is 50 mm, and it is kept perpendicular to the VP. Now if it is perpendicular to the VP, in front view you will be able to see only a point. That line will appear as a point only. And from top view, in top view you will get a line which is perpendicular to XY line. In top view you will get a line which is perpendicular to XY line and having true length, that is 50 mm, the true length. So first draw XY line, and now distances is perpendicular to the VP and 20 mm above HP. So this point is 20 mm above HP. So this entire line is appearing as a point. This point is actually entire line, and this point is how much? 20 mm above HP. So above HP 20 mm, that take that distance. Now the end P which is nearer to VP is 15 mm in front of P. So first draw P here in the same line of P dash. That point you can obtain at a distance 15 mm. So once you get P, you know that this line is true length. So true length is 50 mm. Draw a line, vertical line, which is perpendicular to XY and equal to 50 mm from P to Q, and that's how you will get projection front view and top view of the line PQ. Now the third case is a line inclined to HP and parallel to VP. Now here again let us take a line. Now this line, I have taken a line AB which is inclined to HP. This inclination, I am representing this inclination as theta, and it is parallel to VP. How it is parallel to VP? You can see that distance of A from VP is same as distance of B from VP. So distance of B and A both are at same from VP are same. Therefore this AB is parallel to VP, but it is inclined at some angle. That angle is represented by theta. So when you look from this side, front view, in front view you will be getting same length of line, same length, whatever be the true length of AB, the same length you will be getting in front view, and this same angle also you will be getting in front view. So in front view you can see that same angle, whatever angle it is making with HP, the same angle you will get in front view with true length. But when you look from top, now A and B both are at same distance. So when you look from top, so A and B both will appear at same distance from XY line, like this. So distance of A, it will appear here, point B it will appear here, and distance from this XY line will be same for both A and B. So this is my top view. So its distance from A and B will be same. these two distances will be same. That means you will be getting a top view which will be parallel to xy line. So you will be getting a top view which will be parallel to xy line. But at the same time, you can see when you look from top, this line will it will appear shorter than the actual length. So when you look from top, this total length is, if it whatever is the true length, you will be getting a length lesser than this true length. It will appear as smaller than this length. So remember that in this particular case, when line is parallel to xy line, that line is always shorter than the actual length. So this is how you will be getting in your drawing sheet a dash b dash true length theta and AB which will be shorter than the true length and parallel to xy line. Now next case, where line is inclined to VP and parallel to HP. Now in this case there are two planes HP and VP, and a line which is inclined to VP. Now we represent that angle as phi, and this line is parallel to HP. That means distance of A and distance of B from HP are same. Therefore they are this line is parallel to HP. When you look from top, you will you can see this entire length. You will get entire length here. You can get true length of AB here in top view. Mark this top view AB, and same angle, whatever angle is there from VP, the angle of AB from VP, same phi angle you will be getting in top view. Now when you look from the front, this B and A both are at same distance from HP. Therefore these 2 points will be at same distance from XY line. Therefore this line will be parallel to XY line. But again AB, which whatever be the length, it will appear smaller than that true length. So it will be smaller than true length but parallel to XY line. This is A dash B dash. This is front view, and this is what you will be getting in your drawing sheet. True angle, true length, true angle, length smaller than true length and parallel to XY line. Now let us take one example, a line of 100 mm long. So line is 100 mm long, true length is 100 mm. It is parallel to and 30 mm above HP. So it is parallel to HP and its distance from HP is 30 mm. So all points of this line will be at same distance from HP. So in front you will be getting a line which is parallel to XY line at 30 mm height. Now its two ends are 25 mm and 50 mm in front of VP respectively. Now the 2 points, if you say a line as AB, if name of line is AB, then A and B, that is in top view, A will be at some distance. You can take at that distance as 25 mm. Then other point will be at 50 mm in front of VP. Now we have to determine we have to draw projection of line, and we have to determine its inclination with VP. Now first step is you have to draw a line, name that as XY line. So now you know that a line is parallel to and 30 mm above HP. So in above HP you should draw 30 mm above HP, draw a line parallel to XY line. So draw a line parallel to XY line, but we don't know what is the length of this line, because we don't know what is the length of this front view, but we definitely know that that length will be less than 100 mm because 100 mm is the true length. So just mark this point, one end point as A. So mark that point as A. It is a front view, so we are marking it as A dash. And from A dash draw a vertical line. This is our projector line. In this projector line only you will be getting another point A. Now one point is at 25 and other point is 50. So you assume that A is at 25 distance. So from XY line take this distance as 25 mm and mark point A. So this point also you have obtained top view of A dash, that is A, which is 25 mm from XY line, because it is given two ends are 25 and 50 mm. So one end I have taken this end as 25 and other end will be taking at 50 mm. Now how can you draw? Now you can see that another point is 50 mm in front of VP. So you will be getting B at a distance 50 mm from XY line. So what you have to do is draw a line which is parallel to xy line. Now parallel to xy line, I have drawn one line which is parallel to xy line and at a distance of 50 mm from xy line. So my B will come in this line only, because all points at this line are at a distance of 50 mm from xy line, and it is written that second end of the line is 50 mm in front of VP. Now we know that in top view, in this particular case, in top view we will be getting true length of the line, that is 100 mm. So take center A and radius 100 mm and cut an arc. So take center A here and radius 100 mm and cut an arc, and you will be getting an intersection point. This mark this point as B and join A to B. So this is my final top view, because top view will be of true length 100 mm. So I will be getting this AB as 100 mm length. At the same time, I will be getting B at a distance of 50 mm from xy line. So this distance is 50 mm because we have drawn this line at a distance of 50 mm from xy, and this length is true length, that is 100 mm. Now we know that B dash will appear in this same vertical line when we draw a line. In this case, we should draw a line perpendicular to xy line from B, and in that line only we will be getting B dash, and it is the intersection. We know that it should be parallel to xy line, so it is intersecting at this point. Mark this point as B dash. Now A dash B dash is the final front view, so make it thick. So make this line as thick line, and now mark all the dimensions. This is 30 mm height, this is 25 mm, this distance. Now this distance is 50 mm. Now measure this angle. Use your protractor and measure this angle. This is your required inclination, and it is coming about 15 degree, 14 point something, or you will be getting 15 degree if you measure this angle. Now let us take another example. Here the top view of a line is given, which is top view of a line which is 75 mm long. So true length of the line is 75 mm and top view measures 50 mm. So length of top view is 50 mm. So these two things are given: length of top view and actual length, true length of the line. Now this line is in the VPO. So what you have to do? First step, draw xy line. Now since this line is in VP, top view will come in xy line only. So in xy line, top view will come, and length of the top view is already given 50 mm. So in xy line, draw a line which is of length 50 mm. Draw a line which is of 50 mm and mark these 2 points as A and B. Now it's one end being 25 mm above HP. Now one end, let us take A is 25 mm above HP, so A dash will come in this line. So you can draw from both points, from A and B both, you can draw projector lines. Just draw projector lines from A and B. Now distance of A, that is front view of A, is 25 mm above HP. So just draw A dash here at a distance 25 mm from xy line. So this distance is 25 mm from xy line. Now true length 75 mm. We know that true length is 75 mm. Now we also know that B dash will come in this vertical line only. So what you have to do is take center as A dash and radius equal to 75 mm and draw an arc which will cut here. So draw an arc. So you will be cutting this arc. Now this length, join and mark this point as B dash, and join A dash with B dash. That will be your final front view. Now you can give dimension. This dimension is given, so this is 75. This dimension is also given, 25 mm above HP. So this dimension is also given. This is also given, so mark that dimension also. No, nothing is required here. Only we have to draw projection of the line. So we have drawn this projection of line AB, and A dash B dash only thick line. All other lines should be thin lines. Thank you for watching this video.